Hello, and welcome to another Skellig video. My name's Paul O'Sullivan, and today I'm with Purnendu Saptarshi, one of our long-standing Skellig engineers. Purnendu, I think, is employee number 4 or 5 at Skellig. So I think you started back in like January 2013 or something like that. So
2014. Yeah.
2014. Okay, yeah, very good. Can you maybe just give yourself a little bit of an introduction, and we'll get into what we're going to talk about today.
Sure. Hi everyone. My name is Purnendu Saptarshi. I did my bachelor's back in 2009 from India, Pune. After that, I was working with Emerson Process Management for 3 years. And after that, I did my master's through Ohio State University in 2014. So my major focus always has been instrumentation and controls engineering. I was predominantly exposed to the instrumentation side of things through my bachelor's and then control side of things through my master's. Since 2014, I have been working with Scalable Automation. Great company, by the way. But yeah, so that's my journey, and I have been providing services to different clients for scaling over the period of now 11 years.
Awesome. Yeah, in that time we started together where we used to work together side by side as automation engineers at Skellig, and then I stopped engineering in like 2018 to do management or just be the CEO or whatever and do management full time off Skellig. But what I think is interesting, what we're going to dive into today a little bit is like just talking in general about like where we're at as an industry in terms of legacy automation, all the 4.0 stuff that you and I are very involved with. And I'm very passionate from a business side to see industry unlock what I perceive as major advantages to 4.0. But, in this today, 2025, where we hear announcements such as like Eli is investing 27 billion in bringing manufacturing back to the United States or increasing their manufacturing footprint. You go down the list, right? Fuji, Regeneron just had a huge announcement about 3 billion. J&J has a big investment. Roche has announced a big investment. And then, you think about when it comes to the plant floor and the decision making around the platforms. And in 2025, we're very much, I think it's fair to say, we're very much in legacy automation territory. 4.0 has not made a dent on this market yet. I'd love to dive into it, why you think that is, and where you think the smart money goes, from a business perspective. But then when it comes to the automation, how should we be thinking about this, and how should we temperature check exactly where we're at today? Because you could say, well, like, I mean, the legacy stuff is more expensive. You're going to spend millions and millions on licenses. You're going to have limitations when it comes to data, but you're going to get a tried and true product that's going to get your product out the door. And everyone from regulatory to validation to, all the support infrastructure you have on a site is familiar with this legacy platform, these platforms. So there's a huge amount of advantages, and 4.0 is quite the challenge. I think 4.0 is very much a data-driven conversation or data-centric conversation. And I don't think the two worlds are speaking the same language, because especially in life sciences, it's all about that SATA structure. It's all about the batch logic. It's all about the MES you put on top of it and how it interacts. And there's a growing concern around data, but there isn't, from what I've observed anyway, there isn't a huge emphasis on data just yet in the manufacturing area. But I'd be curious to know what your experience is and how you feel about it,
Yeah, absolutely. I mean, if we start with the basic question as to like, are the legacy systems relevant in the short term? The hard and honest truthful answer is yes, they are. And the main reason for this is I'm coming from a background of a regulated system implementation, not a general purpose automation implementation where things are much more open and easily changeable. So in a regulated industry, there is a huge amount of oversight that is required from all of the auditing organizations, and for like global companies, it the basically it goes across different countries. So they have to be essentially compliant with all the regulating bodies just to make sure that the product that they are manufacturing, quote unquote, I would say like drugs or pharmaceutical products or active pharmaceutical ingredients, even, they're highly regulated. And that is one of the key reasons why this industry is slow to adapt and change its course. Simply because people, as human nature goes, they want to be safe, and they want to basically be doing things that they know best. And that has been essentially in the industry for over 30 years at this point of time. So that is the root of a lot of these industries, where their head is at, in my opinion, where like they're investing money in the legacy
Right.
manufacturing. That makes
Yeah,
sense.
this is probably not the ideal question, but like when you think about that, right? You mentioned regulatory, and straight away I'm thinking, oh yeah, in America, here in America, there's a lot of regulatory, but overseas, there's poor oversight of a lot of those API production facilities. It's a known problem. It's a known challenge. Um, do you feel like, because I'm all for regulation and safety, but do you feel like we need to mature that part of the conversation so that we're better at being able to tell the truth about what happened on the plant floor? And that's where we begin a newer conversation that might enable more 4.0 technologies. Whereas the conversation right now is, well, what can I prove? What can I stand over when I'm interacting with these regulatory bodies? And these legacy platforms are built, they're familiar, they're built for that. You see a lot of them getting installed in the large pharma companies. But when it comes to like the CDMOs and some of the players overseas in low cost environments, they're going for like the most rudimentary thing possible. Everything's on paper. They're mixing in tanks. There's no historian. Uh, there's barely any software oversight. So it's really hard to tell a credible story. And that's
So in
challenging.
that sense, I will kind of come to a problem statement here is like, in United States especially, we have cutting edge technology and cutting edge science. In overseas, a lot of places, their main focus is manufacturing whatever is available in a low cost. So there is a huge emphasis on repeatability, on what is already proven, and not so much of a research or a cutting edge technology implementation. Versus in the United States, at least we have the upper hand, I would say, where the it is happening, the science or advancements in technology and science are happening here. So that I feel that is a major hurdle in pushing the latest technologies in a country where they are not really, as you mentioned, like as much as regulated or have an oversight, simply because they are not, in my opinion, interested in investing in that type of research. So that's a huge difference between the
Right.
end goals of this.
I couldn't agree more. Yeah. But then I think what frames the conversation strangely for me then inside these legacy discussions versus 4.0 system discussions, you should be able to just make a pure technology choice, but I don't think you can. I think you got to consider all these factors. And then you end up with a high cost of manufacturing and a data poverty in the United States, and then you have low cost, but also poorer data in some of these low cost uh, places. And the promise of 4.0 is, well, we have sensors on everything. It'll work like your phone. It'll be able to track everything. You'll know what exactly happened. Like how many people have been convicted of murder because they had their phone on them the time they, did something. Or, we believe these technologies. We can report. We can convict. We can understand the world and what happened based on sensors and technology. But then we go, you leave your phone in the closet and you gown up and you go in the suite and it's like it's not even close. It's like We're talking about tag rationalization or something. 2025, heading into the future, I think the future of a lot of the work, touch wood, for Skellig is going to be large scale DCSs. There's still huge demand for that. I'm not sure how I feel about that, you know? I mean, it's fine from a business standpoint,
Right.
but from an industry standpoint, I wish we were further ahead because there's these massive investments coming now, and there's a lot of stuff going to get baked into place. And I just wish 4.0 and the maturity of these systems was a bit further along so that this was a more interesting conversation right now, other than like, no, no, we're just going to do the default. We already know what the plan is. Just build it. Go ahead and build it.
Correct.
That's kind of a little sad to me. When you look at the 4.0 landscape, then I think it's a lattice, it's a collage, you know, and it's risk, risk, risk. That if you're an automation leader or you're an executive, you've got, you know, 5, 6, 7 different new companies, different POs, different vendor relationships to manage. Like you said, there's, you know, a whole range of new technologies coming online. Which one should you pick? Which one should you use? How do you choose? What's your strategy? These are all new questions you're not ready for, yet you've got to build something. So you're going to go the old school route, you know?
So I feel like Skellig, as a Skellig engineer, we can be a catalyst in bringing about the change, albeit slowly, because the mentality has to change from client's perspective as well as the integrator's perspective as well.
Yeah.
So as a 4.0 oriented integrator, when we are supporting our clients, it does give us an opportunity to prove the concepts, especially I feel like in a lab scale to begin with, because labs are not as highly regulated entity within a pharma organization as your GMP manufacturing would be. The immediate or a short-term goal for a company like us should be to have partnerships with our clients where a 4.0 conceptualized system is implemented in a lab environment. And why I'm saying that is because it's easier to get the data. Our 5 principle is connect, collect, store, analyze, visualize, those kind of a roadmap. It's easier to tackle those situations in a lab scale because an engineer can just walk in there with proper, of course, authorizations, but with a less regulated equipment and prove a concept rather than going into a GMP environment and do the same activity. The easier wins over here would be implementing a system for the client to see and reap the benefits out of them, at least on a short scale basis. And then essentially the beauty of the 4.0 system has to be that they are scalable. So essentially start small, go big. And then that has to be the mentality of inculcation of this philosophy. And that's where the labs are the easiest access. And it's not like every time we walk in a door, we have to develop everything from scratch. As a 4.0 integrator, we can have a bank of knowledge, especially around connecting solutions, implementing, like solve one problem in one place, but then make sure that you can apply or take the learnings on other places as well. So that is kind of a big win, I feel, in a short-term basis. And the second portion of that, take that lab scale automation that is implemented and then translate it into a GMP facility environment. So once you prove it, all we then need to do is make sure that 21 CFR Part 11 compliant items or objects are satisfied with the implemented solution. So we can take all our accumulated experience over past years and then essentially implement the system so that it is out of the box compliant, but it's still implemented in a non-regulated environment to prove the concept. And then that way people will get exposed to it. Exposure is also not just sufficient in this case because a role of a traditional engineer is also kind of evolving. So essentially, they also need to upskill in terms of usability of the newer technologies, and the analysis part of it is also quite important, because like a lot of this is going towards like, oh, I want to use AI. That's the buzzword these days. But people, what miss is like they just don't have the infrastructure to have the data available that you can actually readily use in AI to provide a context, like model training and all of that. So that's what I feel is like the biggest win to start off in 2025 through 2020, maybe like a couple of more years or 3 years, is have a foot into the labs, have the infrastructure built in, get the data, store the data, and provide access to the data to all these smart scientists who can then readily use their algorithms, essentially data science algorithms, to start making sense of a lot of this data. Because right now, what happens is like vendors have their own systems, which are a lot of times siloed, and then specialized knowledge is required to even understand what that data is, and that's where like all the cutting edge working scientists will come into play, who have their specialized PhDs, who exactly know what they are looking for. But having that data accessible to a group in general is a change of mentality, and then that's where people will need to upscale and make sure that that data is actually available. So Skellig's role is, from a stack perspective of S95 or even SIT8, I would say like there is a huge amount of potential and work that needs to happen in lower levels of stacks, so that we can effectively connect an equipment, collect the data out of it, and then the storage and other parts are mostly we can leverage from a computer science background or an IT field, because those problems are more or less solved on that layer.
I don't think it's very costly or hugely, it will be amazingly efficient. But, all those labs that have like benchtop equipment, just start wiring them up to a simple unified NASS, just start streaming the data back so that you can get off this paperwork and we can start moving away from things and just, have some tulip or something like that then for some basic functionality, log booking and other things such as that. But okay, so what I find interesting though is you think that's a good place to start. And I've heard that before. I think even Walker Reynolds thinks that's a good place to start.
Correct.
And I don't disagree, but I think there's a hugely different conversation and maybe it's a hugely different philosophy. Maybe when you look at process automation and the manufacturing side of things, like if you look at our jobs in a lab, it's like, oh, connect the equipment up. You're plumbing, right? You're doing data plumbing. But then when you're on the process side, you're talking about like, which valve opens when, how do you build the sequence? What about this? What about that? What's upstream? What's downstream? Is there CIP? Is there not? It's a huge specialty skill set.
Correct.
But it's a data rich environment that just because of reasons like you just mentioned has to continue to pretty much remain untapped. I think you can make an argument that you can say, well, no, legacy systems, they are good at connecting to your enterprise historian. So what are you saying, Paul? You've got all the data you want, and do you?
So to that effect also, like, I mean, legacy systems are also going to mature at some point of time. Like you see the
What does
efforts
that
from
maturity look like to you? What if you were in the design room for one of those systems and you were like, we're going to mature, guys. What is the design element that's going to mature?
so I mean, in my experience, the data is there for most part. The only or majority of the things from a legacy perspective is like to exposing that data in an open format. A lot of the legacy DCS systems that exist today, I'm not even saying about PLCs, because PLCs have already
Yeah, I know.
matured a lot.
Yeah.
They readily, or most of them readily expose the data over Ethernet or Modbus or one or the other protocols, or now even MQTT compatibility is coming. From a DCS perspective, however, the major step that the vendors of DCS will have to take is exposing the data to the systems that are able to consume the data. I'm not going into like a cybersecurity or a data security perspective over there a little bit, because that's a whole different conversation and a whole specialized area that people do work currently and are really concerned about, of course. However, in a traditional manufacturing facility, you a lot of times will have an air gap between your IT and OT systems. So realistically speaking, fear mongering is not the way to go about data security. You do have precautions already built in. Uh, I think that's how I think about it. A lot of time, what happens is like people start talking about IT terms like cloud data and then where it is, and you just push the data in cloud. The problem is that then where is that cloud located? What is the infrastructure? What is the data security over there? Totally valid arguments, but when we are talking about like all these legacy manufacturers, they are not giving you access to their data even right now. So nobody is ready to even push the data into the cloud. So that's where my suggestion kind of is like, okay, start with the labs, make sure like you have an on-prem sort of storage, implement the infrastructure, see the benefits yourselves, and you will have those benefits definitely. Like, for example, Chris just joined us. The project he has been involved with in past also, it's geared towards this, is like get the small wins and then transfer that technology into your traditional manufacturing. And again, the manufacturers of traditional DCS are also working towards that. It's like, yeah, we are MQTT compatible. We have OPC UA, for example. Like we have the data availability. Though limited, it's a step in the right direction, in my opinion. So after a few years, maybe 3, 4 years, we should see a more receptivity towards sharing of the data. And those would be a game changer for them as well. From a relevance point of view, is like if they want to be relevant with the current solutions that are implemented, which is huge billions of dollars.
I want to ask you about something really quick you mentioned there, just around connectors and things like MQTT. And like, so let's say a legacy DCS or some hot new MES system comes out with like, oh, we now have an MQTT connector. What would you advise a client to watch out for? Because what I'm getting at is connecting to MQTT or anything else can allow you to connect obviously to other systems and pull that system's data in. It does not mean you are now publishing all of your potential data. How do you sniff out that, like, oh, look, they just advertise they have MQTT connectability or God knows what, who cares, whatever system. But what's the philosophy behind that? And I think when you say step in the right direction, I'm not sure I agree. The one I'm looking for is the philosophy one. Like Ignition, right? Ignition's good at like very friendly with data, in, out, no problem. But like there's other systems in that are not so good. They have the connectors, but they're looking to kind of, it's easy to get the data in, but then they kind of make it a bit awkward for you to get stuff back out. And that's a business strategy, I feel like.
That's where I'm thinking is like, if they are honestly implementing solutions not just for the buzzword of things, then that's the step in the right direction. But at the same time, like a lot of vendors will announce like we have this OPC UA connectivity or like MQTT connectivity. However, it of course has to be proven in the field. I have had a lot of experience where vendors claim something, but then they only claim to get in the door. But ultimately, I mean, that's a reality also from a, I think from a, I guess, funding perspective. It's like they want to do it, but then they haven't really thought out the solution in the full capacity. And at
Agreed.
this point of time, the relation between vendor and the client, or a user from our perspective, becomes very important, where the OEM vendors then should be open to making modifications to their piece of software. And that is what I have been seeing a lot as well. It's painful initially where to open up the conversation with an OEM vendor, but it is happening in the industry, especially lab scale equipment that are getting transmuted, I would say, to a traditional GXP manufacturing space.
Yeah,
Uh,
yeah, yeah.
a lot of these start small, They say, okay, we are going to give you X protocol connector, which is a legacy, conversion of data. Especially now, the hot topics are OPC, UA, and MQTT. But they say that we are going to work. When you actually go to implement that solution, you start finding issues. But then that's an iterative process. That's where the software engineering lifecycle comes into play. It's like traditionally automation engineers were like, okay, valves, motors, solenoids, panels, wires,
Mhm.
voltages. They were not as concerned with a life cycle of a product or a SaaS. They were traditional waterfall manufacturing. Is like, I'm going to order my panels, I'm going to get the panels, I'm going to wire them, I'm going to lay the cables, valves will be here. It was pretty standard thing. Whereas now the concepts of software engineering or software lifecycle, we have to inculcate into the OT field. And that's where the industry is kind of having friction, because that is a new concept to an automation OT field, not so much of a concept for like new concept for IT side of things. So IT is very agile, OT is not. So that's where the things start getting frictional. Is like, oh, you said this, and I am getting complete something different. So
Right.
there's that disconnect. But you can overcome that, having a right outlook and having a right mindset of clients and vendors. And this is what I've been seeing a lot as well, is like there's no point in um, getting frustrated over a vendor. Like, you just have to open up a dialogue as a client and say that like, okay, you provided this, but now what I was looking for, actually these requirements. A lot of time I'm also seeing is like the clients themselves are not sure about what their
Right.
requirements are,
Right.
because it's so changing every day. Even the cutting edge cell and gene therapies, and then the viral vectors and all of those therapies, a lot of times the processes are not yet set in stone as you would go with a like a mammalian cell culture or that type of traditional manufacturing. Like, that is there, that has had time to mature over like last 20-30 years. This
Yeah.
is a very new landscape.
But there's so much
Yeah.
power in the power of buying or not buying something, and all these vendors
Right.
compete. But I think too often, maybe in some of these conversations, the user requirements are not established up front well, or automation's not considered. So then these user requirements are kind of taken job to job by some of the middlemen, the A&E firms, who are actually the ones kind of setting up the big process. And in the selection criteria, yes, it does involve the client and the scientist, but the scientist is looking like, do I have my, but from an automation and a longevity of the operational effectiveness of the building, that's very poorly considered. My experience, just on the outside looking in with the middlemen, is they don't pay enough attention to that. They're really just looking to get it done with the vendor packages. And these vendor packages, they float in by hook or by crook, and they're there, and the long-term facility then is just kind of left holding the bag, so to speak, with a lot of complexity and diversity in this new world, which is now software oriented, and now you've got a little bag of stuff to try to connect to.
There is some truth to it, and there is another side of it is like, as these technologies are being developed right now in this time frame, a lot of times you do not even have choice for vendors. So that is also
Yeah,
truth.
yeah,
So it's like, oh, you want to maybe do an assay on some sort of like cell culture or whatever. There is probably only one vendor that currently does it, and they have not really developed it as a 4.0 system to begin with.
yeah,
So when the manufacturing, even for that sort of equipment, will mature, we will have more options to have multiple vendors. So essentially, some cases it's more monopolized at this point of time, but you have to have a knowledgeable person who can assess all the pros and cons of whether A, I have an option, B, there are options, but then from what makes sense from an engineer's perspective versus a scientist perspective. Well, scientists will say like, oh, this particular vendor has an equipment which does a phenomenal job, but then it's not really exposing the data you want. But then there is vendor B, which does an okay job, but exposes all of the data. And at that point of time, we have to make the decision
Yes.
of, it's like, oh, we are going to buy both and then maybe have leverage again, one after the other. It's like, hey, this vendor offers the data, then can you do this or something like that?
Yeah.
So that would be a money conversation from a funding conversation where how much manufacturers are willing to invest. We cannot make up money, unfortunately. So
No,
that's where the conversations would go.
there's a political or a business influence problem there. The W. Edwards Deming talks about like how you interact from a quality perspective, how you interact with suppliers and vendors. You pick one supplier and then you work with that supplier to make your product better and your factory better, rather than creating this kind of fake competition that doesn't really result in a value add, but a lot of hours are spent comparing like for like or differences, and then choices get made for non-scientific or non-holistically beneficial reasons. As you're talking, I'm kind of thinking like, I'm hoping for change and I'm hoping that things kind of mature towards a more data centric way where we can do more with data. But I also, you don't want to lose all the beauty and sophistication that you get from your legacy DCS and the phase logic, your EMs, your control modules, your stable approach, your MES that you have. What do you think the conversation would be in 2 years, and how would you answer the question like now versus I wonder would it be interesting if we talked in 2 years, like some of the following questions, like if you were tasked with $100 million today and you were like building a factory, um, let's imagine the process is, let's make it simple, let's make it a MAB, right? It's a MAB process. You're there. Purnendu Saptarshi Industries is going to build a factory. You've got 100, 200 million, whatever, right? You've got enough money. You're spoiled for choice, and you got to make some decisions. Are you insisting, or are you driving any strategy into the company? What decisions are you expecting on your plant floor around your automation in 2025?
If I'm getting that kind of money, right, like then I would at least go and venture in or work with partners like Scaling, right, who can offer a solution which is out of the box compliant, first of all. For example, if Skellig makes a product where Skellig stands by, it's like, okay, we
Oh,
will
yeah.
support this solution, prove it. For example,
Yeah.
it's like we have an ignition as basis, we had Canary as historian, we had Git for version control. So I would actually invest in a system that is even small scale, have it proven. It's like, okay, all these 21 CFR Part 11 compliance you can implement in a particular way, right? And then the biggest portion will be it is scalable. What advantage we are going to have in this world is like it has to be understood that it's an ongoing process, not like a traditional manufacturing where you would have like a X amount of money and you are done pretty much it, and then you keep extending that money over and over and over again.
Yeah.
Start with small and then repeat it enough times that it becomes a larger process. So that's where my head would be. Get a system in place which is scalable by its nature, implement it, prove it. Yeah, this works as a prototype, and then expand on top of it. And we do have good contenders, not just Ignition. There is Factory Talk, which is 4.0, and then the Siemens Vensis COA is also another. Everyone is trying to build the system of the future. So we can take an advantage of it and make sure that it's scalable by its nature. I like what Walker Renault says, like write your requirements not based on the available vendor or software, write your requirement based on technology. And as long as we do that fundamentally, the job of validation and maintenance will be much, much easier because in that case, you are not stuck with like to like
Yeah.
um,
Yeah. No, I know.
philosophy. Is like my one of my pumps broke, but I cannot buy any other vendor's pump because my documentation is set like that. That is a conversation we have always had multiple times. So we need to break out of that mentality.
Yeah.
So writing a system documentation which is by its nature based on technology and not a specific vendor would be my goal essentially.
I often seen projects start out trying to do that, and then they get lazy as you get through the iterations, and it's like, well, it's labeled this in the platform that we want, so we just call it that, you know. And you
Right.
start to see very suspiciously familiar names pop up. Then I think about today, and I think about like, if my job was automation manager, or automation director at a pharmaceutical facility, I think it's quite a scary time, and it's an intimidating time to try something new, because I don't think that a lot of the 4.0 stuff has proven itself collectively. It's ticking some boxes from a data perspective, but it seems like there's pretty immature solutions when you look at like something holistic. And I think that's a challenge. And I think that's something we have to address. We have to make 4.0 safer to choose, yeah, for these people that are trying to have a decent career and not get fired because you chose some quote unproven solution. So I agree with your assessment. You have to start small and prove it out internally. But I think the reason you have to do that is because 4.0 is fragmented. Uh, 3.0 is consolidated.
Again, it's a mentality question, right?
I
Like,
know.
so we have to have managers who think about like a 4.0 people, not a traditional manufacturing. And in short term, people will make choice of 3.0 systems just because they are proven, they have a track record, they have a robust, and they're not bad, right? Let's be honest. They're not bad in terms of the job they do. They do get the job done. However, they are, how to say, they're not futuristic, and you are essentially not able to get the best out of it. That's the goal that 4.0 mentality is trying to solve. Um, I think so. Like, so do more with less, and all of that philosophy essentially is like you have to optimize somehow. And the
Right.
optimization will eventually come from accessibility to the data, because if you are losing the data, you don't have insights to an existing system. You are losing on the, how to say, like all the buzzwords of like digital twin and like implementation of AI and making sure my system is futuristic so that I am doing predictive maintenance, predictive everything to maximize essentially the throughput, right?
Right. And that's where it gets tricky, because yeah, people think futuristic is better, but we got to get good at helping people understand the criteria by which is better. Like, oh, just because it says it has a connector doesn't mean it's generous with data. Your goal and your strategy should be do more with data. We're going to be a data driven company. We're going to use our data. We're going to share our data. We're going to have systems that talk to each other. We're not going to pick systems that don't talk to each other. Like,
Correct.
that's where this kind of begins with a strategy, and then from there you can kind of collectively start the snowball, you know,
Correct.
towards
Correct.
productivity and feeding back information and getting people to do more um, on the plant, feeding data back down to the plant floor for people to
Correct.
make healthier decisions. One things I see or worry about now, you look at all this investment that's potentially coming, you look at it all hitting around the same time. Do you think that there's a high likelihood we're going to end up with COVID style supply chain issues again into 2027, 2028, where we'll have resource constraints around engineering because of too many projects going on at the same time, and it's all the same old, same old. So you need a huge volume of engineers, and AI is not going to cut it. And then you go to the hardware side of it, and you're going to need controllers out to wazoo. So the back orders are going to be significant into 2027, 28. Projects are going to get wildly delayed, and we don't have a mature strategy yet, or maybe customers or companies haven't started thinking about hardware independence yet. And like, how could you choose your legacy DCS? But if you start hearing answers you don't like around hardware, what are your alternatives? Because there are alternatives from a hardware independence perspective. You can choose, you know, you can do your vendor management stuff and choose your vendors, or whether a PLC, and create wrappers, right? You do that, but there's also edge devices, edge controllers like Opto 22, etc., and you can start to build out a framework there, and then you could feed into uh, and all the expenses legacy DCS. Not saying I love that solution, but just wondering what people what people are going to head towards. Do you have any thoughts or any kind of near term predictions?
What I also see these days is like the industry is going towards the OEM style manufacturing. It's
Yeah,
like you
yeah,
have one OEM that does a job well. They're most of the time they're a PLC based. The PLC resides on an equipment, and a lot of this just comes as a package. They have their own validation done. They have whatever specific requirements done, so on and so forth. That is where the market, I think, is headed. So, from a automation integrator perspective, what we are looking for a future is a quarterback, essentially who is not just a SCADA but an orchestrator as well. So, SCADA is just going to be looking at different system and consuming data from an endpoint perspective. However, the orchestrator then can also perform some SFC type logic where you can sequence different actions one after the other. So this is what I'm kind of thinking is have the control in a distributed manner, in a spirit of distributed manner, in the sense the brain is
yep,
distributed.
yeah,
Traditional DCS kind of try to achieve exactly that. However, their database management becomes central. So that's where the disassociation starts coming into play. However, when we are talking about like manufacturing, there is a lot of other conversations like liability and standing behind their solutions. It's like it's always easy to say that I'm buying product A from vendor A, and then they are standing behind their solutions. So it becomes a strategic investment rather than a company taking ownership of all of the code base equipment, whatever developed in house. So
yeah,
that's where I see the industry going in the meantime. So again, same thing. Our job should be that this quarterback is 4.0 centric, where you are not limited by only one vendor, one solution. Tomorrow, the vendor, if they pick and choose from one PLC to the other, we shouldn't be at the mercy of that
yes,
supply chain. Like
100%.
all we care about is like I'm gonna go and buy a bioreactor from this vendor, and then it satisfies, it check ticks all my boxes. The data contextualization that I have today, even if under the hood changes anything, for me, the data contextualization still remains the same. So if that sort of templatization occurs, it will be an easy, not easy, but much more viable implementation of 4.0 industry philosophy in the manufacturing. So that's where my head is at. That's what I'm seeing.
Yeah,
A lot of companies doing traditional DCSs are kind of becoming just a shell. Like you just
yeah,
have a shell to communicate with or connect to a vendor. The data comes through the centralized DCS. It is passed through the historical.
okay,
So that sort of hybrid solution is kind of what I'm
yeah,
thinking.
okay, yeah. Let's leave it there for now. But
Sure.
this is a great conversation. I'd love to talk more to you about that because I could keep going all day about this. Is
Yeah.
fascinating. 'Cause I kind of disagree, or sorry, I don't have a credible leg to stand on because I haven't done technical in a long time. But if I had my hopes and dreams, I want to be fully integrated. I want to see data flowing in all directions, and a data model like so the vendor packages and the differences up and down the suite of equipment kind of bothers me a bit. But all right, let's leave it there for now, and maybe we'll talk again pretty soon, and we can have
Absolutely.
continue. Um,
Nice talking to you.
Tarshi, thank you so much, man. I appreciate
Take
it.
care.
Yeah.
Bye.
Bye
Bye.
bye.